Hello children, I am Mohammad Rizwan. This article will talk about square roots and cube roots and fun methods to learn about them. A square root of a number is defined as a value that the original number when multiplied by itself. Examples of square roots are 9 is equal to 3, 16 is equal to 4, 25 is equal to 5, and so on. When we multiply 3 by itself, we get 9. Thus, the square root of 9 is 3. Similarly, 4 is the square root of 16. When we multiply the number by itself, we get the square of a number. For example, 3 into 3 is equal to 3 square is equal to 9. Four into 4 is equal to 4 square is equal to 16, and so on. Thus, the square of 3 is 9. So, we can say that the square root of 9 is 3, whereas the square of 3 is 9. Based on the same concept, if we multiply the same number thrice, we get its cube. For example, 3 into 3 into 3 is equal to 27. Also, the cube root of 27 will be 3. Between 1800 BC and 1600 BC, the Yale Babylonian collection YBC 7289 clay tablet was created that spoke about the square root of 2. A copy of the Rind mathematical papyrus from 1650 BC shows how Egyptians used an inverse proportion method to extract square roots. In India, the Sulba Sutras, which were dated around 800 to 500 BC, used the knowledge of squares and square roots. Good approximations of the square roots of 2 and 3 can be found in these texts. Greek and Chinese mathematicians also conducted extensive research on these concepts as well as the irrationality of numbers. As time progressed, many extraordinary minds came together to give us the concept of square roots and squares as we know them today. When you go to find a new apartment, you will want to know its size of it. Newspaper and online advertisements usually give the dimensions of the apartment by only listing its area such as 625 square feet. This can become hard to visualize. However, if you use the concept of square roots and convert this number to the form of 25 into 25 square feet, it gives you a better idea of how big the apartment is. Using cube roots can provide a more precise dimension of the apartment. Square roots are also used to find the period of a pendulum. Squares and square roots are used in the Pythagoras theorem. Say you have an erect vertical pole and you want to find the shadow it casts on the ground. By determining a few quantities and applying this theorem, you can quickly determine the length of the pole's shadow on the ground. The concept of squares and square roots is used in all walks of life, such as carpentry, engineering, designing buildings, and technology. After the completion of this lesson, you will be able to know learning objectives. To compute the square and the square root of numbers, to make a rough estimate of the square roots. Keywords from this lesson: ratio, number, odd number, even number, square number, prime number, and perfect square. This is a square of side 1 unit. It is 1 squared. We write this as 1 square equals to 1 into 1. And next we have 2 square, similarly, which can be written as 2 into 2 is equal to 4. And then we have 3 square, which is nothing but 3 into 3, which is equal to 9. Meaning this is a 3 squared. More often, we write like this: 4 square is equal to 16. This says 4 squared is 16. The 2 at the top stands for squared and it indicates the number of times the number 4 appears in the product. 4 square equals to 4 into 4 is equal to 16. The numbers 1, 4, 9, 16 are all square numbers, also called perfect square numbers. Each of them is made up of the product of the same two factors. A natural number, n, is called a square number if we find another natural number m such as n is equal to m square. Is 49 a square number? Yes, because it can be written as 7 square. Is 50 a square number? The following table gives the squares of numbers up to 20. Have a look at it. For 1, its square is 1 into 1. For 2, its square is 2 into 2, which is equal to 4. For 3, it is 3 into 3, which is 9. 4 into 4 is 16. And 5 into 5 is 25. Same is applied for all the numbers ahead. We can now easily verify the following properties of square numbers by referring to the table given above. The square numbers only end with 0, 1, 4, 5, 6 and 9. If a number ends with 1 or 9, its square ends with 1. If a number ends with 2 or 8, its square ends with 4. If a number ends with 3 or 7, its square ends with 9. If a number ends with 4 or 6, its square ends with 6. If a number ends with 5 or 0, its square also ends with 5 or 0 respectively. Square of an odd number is always odd and the square of an even number is always even. Numbers that end with 2, 3, 7 and 8 are not perfect squares. Let me ask some questions. Is the square of a prime number prime? Solution: no. Why? The square of a prime number p has at least 3 divisors, 1, p and p square. But a prime number is a number which has only 2 divisors, 1 and the number itself. So the square of a prime number is not prime. Will the sum of two perfect squares always be a perfect square? What about their difference and their product? Solution: the sum of two perfect squares need not be always a perfect square. Also, the difference between two perfect squares need not be always a perfect square, but the product of two perfect squares is a perfect square. Example: which among 256, 576, 960, 125, 4096 are perfect square numbers? Solution: for 256, it is 16 square. For 576, it is 24 square. same is applied. For 4096, it is 64 square. Therefore, 256, 576 and 4096 are perfect squares. Example: one can judge looking by the look that each of the following numbers 82, 113, 1972, 2057, 8888 and 24353 is not a perfect square. Explain why. Solution: because the unit digit of a perfect square will be 0, 1, 4, 5, 6, 9, but the given numbers have the unit digits 2, 3, 7, 8, so they are not perfect squares. Some more special properties of square numbers. The square of a natural number other than 1 is either a multiple of 3 or exceeds a multiple of 3 by 1. The square of a natural number other than 1 is either a multiple of 4 or exceeds a multiple of 4 by 1. The remainder of a perfect square when divided by 3 is either 0 or 1 but never 2. The remainder of a perfect square when divided by 4 is either 0 or 1 but never 2 and 3. When a perfect square is divided by 8, the remainder is either 0 or 1 or 4, but will never be equal to 2, 3, 5, 6 or 7. Example: the area of a square field is 3136 meter square. Find its perimeter. Solution: given that the area of the square field is equal to 3136 meter square. Let's solve. So by long division method, we find the square root of 3136. 5 5s are 25. We apply that, we need 31. And after subtracting, we get 6. After that, we drop down 36. And then 106 into 6 when multiplied gives us 636. So we get the remainder as 0. And 56 is the square root of 3136 meter. So as per the formula, the perimeter of the square field is equal to 4 into side. Now that we know the side, 4 into 56. And the answer is 224 meters. Example: a real estate owner had two plots, a square plot of side 39 meter and a rectangular plot of dimensions 100 meter length and 64 meter breadth. He sells both of these plots and acquires a new square plot in the same area. What is the length of the side of his new plot? Solution: the transactions can be visualized as follows. Area of the square plot bought is equal to area of the square plot sold plus area of the rectangular plot sold. area of the square plot sold, the side is multiplied twice, 39 into 39 plus area of the rectangular plot sold, we have the length and breadth, 100 into 64. 39 into 39 gives us 1521 plus 100 into 64 is 6400. Adding them up, we get 7921 meters square. So the length of a side of the new square plot is equal to root of 7921. So now let's find the square root of 7921. 8 times 8 is 64. We apply that beneath 79, we get 15. After that, 169 times 9 gives us 1521. So square root of 7921 is 89 meters. Points to remember. A natural number n is called a square number if we find another natural number m such as n is equal to m square. The square numbers only end with 0, 1, 4, 5, 6 and 9. Numbers that end with 2, 3, 7 and 8 are not perfect squares. The square of a prime number p has at least 3 divisors, 1, p and p square. But a prime number is a number which has only 2 divisors, 1 and the number itself. So the square of a prime number is not prime. The sum of two perfect squares need not be always a perfect square. Also, the difference between two perfect squares need not always be a perfect square. But the product of two perfect squares is a perfect square. Thank you for watching.